Hey class, this is Chapter 4, Section 6, and we are heading toward the end of Chapter 4. This is Mrs. Norris, and this is Geometry. I want you to pause the video for a minute, and I want you don't have to write down the original problems, okay? As a matter of fact, if you're listening, I don't want you to write down the original problem. I want you to just answer these questions kind of quickly, okay? Pay attention to number 2. It says A is parallel to B. You're given that they're congruent, so this should be a converse of something. All right, go ahead and work those out. We'll talk about those tomorrow. Okay, part of your homework tonight after you watch this video is to do the end grade quiz. It will be due by 7:45 tomorrow. And one of the questions asks you to come up with a clever, creative way. It can be a quick little acronym. It can be a little rap song if you want, but I need you to come up with something creative that will help your classmates remember CPCTC and what it means. So we talked about before that if two triangles are congruent, now we've learned all these ways to prove they're congruent. Well, if they're congruent, then guess what? All of their matching parts or corresponding parts are then going to be congruent to each other. And we use this rule, CPCTC, to prove that that's the case. So we're going to do some proofs today. All right, remember the 5 rules. This is what you should have answered in your warm-up question. Most of you did pretty well on this for the review packet that you had to do. Let's start with a little engineering word problem application. It says that A and B are on the edges of a ravine, and it gives you a bunch of data. So paying attention to the fact that this is 10 right here, and this is 10 right here, we can add congruent marks there and there. That gives us our two sides. 15 here and 15 here make this congruent to this. That's another S, so we're left with the A in the middle here, which is congruent because of vertical angles. All we're doing is using SAS to prove our triangles congruent. And since the triangles are congruent, then that means that AB, which is the third side of the congruent, has to equal whatever this distance is. So the distance from A to B is going to be 18 miles. And we just write that out in a paragraph form, but we say that by CPCTC, remember, this is corresponding to this side. We prove the triangles were congruent. Let me go back a little bit. By SAS. And because they're congruent, then we can say their corresponding parts are also congruent. So we can say AB has to be 18 miles. Similarly, let's look at this example. You can read the words to talk about what they're doing here, but it's basically a landscape architect is using congruent triangles to design the pond. And he wants to know how long this pond is based off the fact that we have SAS congruence again. You can see that JK must match MN because of CPCTC, so JK is going to be 41 feet. All right, once again, we have vertical angles and SAS congruence. All right, this next one is going to be a proof. I want you to notice something here. We are going to prove that angles of these two triangles are congruent, not that the triangles themselves are congruent. However, we are going to prove that the triangles are congruent in the step just before this one. So that's what you need to remember about CPCTC proofs. We use the SAS or AAS or any of that to prove the triangles congruent. And then our last step or second to last step is always going to be CPCTC. So let me show you how. Okay, a quick CPCTC proof. We're going to do the same thing we did last week where we prove the triangles congruent. But this time after we do that, we're going to add one more statement after that. It's the proof statement here, which says that the angles are in turn congruent. So I've copied our given and our proof statement from the previous slide, and I made my statements and reasons columns. You should do the same. I want you to pay attention here because I'm only going to tell you what I want you to write down, but you're not going to see everything on the screen, so make sure you're listening. So you know how these proofs work. We take a given and we copy it. The first given I'm going to copy is that YW, this segment right here, bisects this segment XZ. So that means that this guy, okay, so the first thing you should do is you should mark this segment getting bisected by this segment. So you should put congruent marks on your picture here and here. After you do that, you're going to write the statement that XW, which you just marked as congruent, is congruent to WZ. The reason, definition, bisector. Now it's technically a segment bisector, but we don't have to add that word, just write bisector. The next thing I want you to add to your proof is an S, capital S right here, right next to this. We've proved one side congruent, and you can even add an S to your picture. The next thing I'm going to do is copy the next given. That's another pair of sides congruent. You should mark that in your picture as an S and as congruent marks, and you should also put an S here. And the third thing we're going to write, which is step 4, is the reflexive property. That YW, try that again, that YW or WY is congruent to itself because of the reflexive property. Now, following the pattern here, you should already realize you should put an S here. Do we now have enough information with SSS to prove the triangle's congruent? We do. So we write that they're congruent and we put the reason SSS. Now normally, before this section we'd stop. This time we're going to go one step further and we can say that the corresponding angle involved, in other words this one up here, XYW, is congruent to ZYW because of CPCTC. And that is a CPCTC proof. You now have until 7:45 tomorrow morning to take the end grade quiz. You are expected to take as much time as you need, up to 10 minutes, and rewatch the video if necessary. You can look things up. Just take your time on it, and I will see you guys tomorrow.